Welcome to this Calculator Project screencast. I'm Lynn Robert Carter of ICarnegie Global Learning. In this screencast, we're going to explore the calculator baseline built upon double values. On your computer, the name of this project may be different, but the implementation should be the same. Inside of the project, we'll find a source package, and inside of that source package, we will find two Java packages, the inexact unit calculator package and the inexact unit calculator main package. We use the word inexact to represent that this calculator works with values that have uncertainty associated with them. When you measure things in the real world, there is some limit to the amount of precision that one can produce, and therefore we record not only the value, but the amount of this uncertainty. And we will see that in the example in just a moment. We use the word unit in the name to also represent that each of these values has associated with them some measurement unit, such as millimeters or meters or kilograms. Inside of the inexact unit calculator main package is a class file that is the main for the program. Inside the inexact unit calculator package are two more classes, the calculator value class and the inexact unit calculator class. The calculator value class describes objects that the calculator uses as inputs and as the result of computations. The inexact unit calculator class is the controller class that manages the buttons and the text input areas and the text output areas and performs all of the computational tasks. To see how the program looks in terms of its user interface, click on the inexact unit calculator main class file and click on Run. This is the user interface, and there are four main elements. There is the first operand, which consists of three parts, the second operand, which also consists of three parts, the operator buttons, which perform the computation, and the result area where the results are placed. So let's see an example of adding two values together. First of all, let's add two values. This first value with two decimal places, if we were to say we know that the number is accurate to two decimal places, then we would specify the uncertainty to be 0.01. And let's assume that this is meters. Let's put the second value here, and similarly amount of uncertainty, and let's specify meters there. When we add these two, we would click on the Add button, and the first thing the computer does is make sure that the units agree with one another, because you can only add meters to meters. So let's take a look at an error message. So let's change this one to millimeters and attempt to add them. And so we see that there is an error here. There's a units mismatch. It is possible to enhance the calculator to recognize that both of these are measurements of length and to adjust one to the other, maybe converting meters to millimeters, and then performing the addition, but this particular implementation of the calculator does not do that. If both of them are meters and we perform the addition, then we get a result that consists of three parts: a value, the error amount, and the units. Now, what's interesting in this output is that we see this artifact of all of these zeros and then this 5. This is telling us that the computer is using a binary representation for these floating point values. Most real calculators use decimal arithmetic as opposed to binary arithmetic, because in binary arithmetic there are certain repeating fractions, such as 0.1, which are not repeating in base 10 or decimal arithmetic. And therefore humans see these zeros and this 5 and assume that somehow the calculator is not functioning properly. In more advanced versions of the calculator, we will use a different math library other than doubles that are built into Java in order to do computation in base 10, and that will also allow us to format the output more gracefully. But in this particular implementation, we have to deal with the fact that sometimes we have these output values where the output value seems to have all of these decimal places, but we can see that it has computed an uncertainty amount based on the uncertainty of the two input values, and this uncertainty amount tells us that this value is only accurate to 0.02 meters. So there's the value, the uncertainty, and the units of measure. Now, if we're to push the multiplication operator, we would see a product, an uncertainty, and notice we have a new units now, meters squared, because if you multiply one length by another length, you end up with an area. So meters times meters becomes meters squared, which is an area. If you press the division symbol, if you divide meters by meters, you end up with a ratio which is free of units because the meters cancel out. And so here we have a quotient, here's the uncertainty, and there are no units associated with this result. This shows you the operation of the calculator. Now let's go back and take a look at a little bit about how the program is implemented that creates this. As we said before, this application is built upon 2 packages and 3 classes. The inexact unit calculator main is a class inside of this package that launches the program, but that's all it really does. The inexact unit calculator.java class is responsible for all of the swing user interface elements and initiating actions. The calculator value class is used to specify information about calculator values, the fact that each calculator value consists of 3 parts, as well as information about how to read in a calculator value, write out a calculator value, and deal with the computation of the uncertainty for each values under the various forms of addition, subtraction, multiplication, and division, as well as the computation of the units given the input units on the 2 operands, what the units for the result should be. So let's take a very quick look at each of the 3 of these various class objects, and then we will explore them in more detail in a separate screencast. The main line is inside of this file, and to see it more clearly, let's move this over, and let's minimize this, and let's minimize that. Now the main line, as you can see, consists of just these 3 lines of code. As a swing application, the user interface is implemented by and supported by a controller class, and that controller class is created here with this new command. When Swing is ready to begin the execution of the program, it invokes this particular method being defined here, and that method consists of just 1 line of code. Create a new object. And so the constructor for that new object is responsible for doing all of the work of setting up the user interface and putting things into motion so that then when the user types into text fields, clicks on buttons, and does other things with the user interface, that the application will do its job. The controller is inside of this class file. This is the controller for the program, and it consists of a number of swing declarations to create the various user interface elements, as well as some other methods to instantiate and implement the various actions. This particular class extends JFrame because this particular object is responsible for drawing the user interface as well as implementing the various actions. The details are not critical, but the objects inside, or the elements, I should say, the attributes inside of this class specify all of the elements of how big things should be, where they're positioned on the screen, what font should be used, and so on and so forth. The last class that we're going to do a quick look at is the calculator value class. And this particular class consists of information to help us or help the computer perform the calculator computations. Each value consists of three components: a value, an uncertainty amount, and the units associated with that value. Inside of this particular class, after we get past a number of other declarations, we will find three private declarations. The first is a double value, the second is a double that represents the air term, and the third is an int that represents the units. That plus the other method, the other attributes and methods inside of this class implement all of the computation aspects of the calculator in terms of performing operations on the double values of addition, subtraction, multiplication, and division. To learn more about the calculator, there's a separate screencast on each of these classes.